today we are going to discuss basically character set topic. Today topic is character set. I can show you here so you can see a bit of it. So have you done practice of last topics? Good. So today topic is basically text, sound, and images. These three topics I'll cover. I will try to cover. Have you heard about text, sound, and images? How to represent in computer form? How computer understands basically these three text, sound, and images. Basically, these are basically input data. We give data to the computer in the form of text, sound, and images. So, do you know how a computer recognizes this one? Is there any idea? Yes, you are right. Maybe code. So there are some codes are generated, or you can say some signal are generated. Okay, wait a second. I am showing you presentation on this. First one, the practice set. Okay, basically, computer engineers have established a list of characters, and regarding character, they have established basically codes. Each character will have its code, and that codes are arranged in a list. That list is called American Standard Code for Information Training. Later on, I will discuss. First, we need to see. So you can see here, a character set is a defined collection of characters, symbols, and symbols that a computer or communication system uses to represent and encode textual information, enabling the display and manipulation of written language and symbols. So that whatever we write data, whatever we give data in the form of text, images, sound, or video, they are converted into binary form. But before binary form, they are given a decimal code. Each character have a decimal code. I will show you a list of decimal code so that computer, and that decimal code is converted into binary code. And then computer understand what has been given data by the user. So first we need to see little theory. Okay, next it says when you press key on a keyboard, a numeric code such as an ASCII or Unicode is generated to represent the corresponding character or function associated with that. Whatever key you press from the keyboard, so it has, like I press A. Okay, I'm giving you writing the example. If I basically write A, it will have a decimal code. So in computer, its decimal code is 65. That 65 is converted into binary form. Okay, and that binary form, wait a second, and that binary form understood by CPU. Okay, whatever processing has to be done, it does, and then it's sent to output device in the binary form. Okay, output device has again character set of that code like 65, and that in the form of binary form, whatever binary form, and that 65 will have a basically capital A. So it will show capital A on screen. So these kind of character will have its specific code. I will show you further, so you can see list of character code. Okay, now see, when keys are pressed, electrical signal are sent to the computer. Which are translate them into character, or command. So it says that whenever you press a key, there is an electrical signal generated. The computer is totally based on electrical signal, 0 and 1 form. Okay, so that computer can understand. A character code is a numeric representation assigned to each character or symbol in a character set, facilitating their storage, transmission, and processing in digital systems such as computers. These are some description of regarding character set. So I think it is clear to you, or should I explain further? Yes, Nama. Is this clear? Okay, good. Okay, wait a second. Now moving to next slide. Basically, these character set. Computer engineer has established these character set in a standard form. That standard form is called American Standard Code for Information Interchange. Little history is given here. ASCII was established in 1963 for communication and computer system. Okay. Initially, basically, they introduced another revised version. A revised version of ASCII was published in 1986. The standard ASCII character set consists of 7-bit code, so ranging from 0 to 127 in decimal or 00 to 7F in hexadecimal. Basically, what they did initially, our character set was 4 bits. Okay. It was called nibble. Okay, but later on they introduced 7-bit codes 0 0 1 0 1 0. So this is a 7-bit code. Whatever character we use, it takes 7 bits. Okay, that 7 bits called byte. Okay, so 2 power 7 means 128 different character can be used by computer. Obviously, computer was upgrading itself. So later on, they introduced another they extend the American ASCII code. That was called extended part 2, ASCII part 2. Okay, wait a second. These codes represent letter, number, and standard keyboard character, as I told you. ASCII also includes 32 control codes represented by code 0 to 31 in decimal. Okay, it means basically they have a range of character codes like capital A to Z. You need to remember 65 onward. I think it will go to 91. So you can add 26 characters. Small a to small z. Small a starts from 97 onward, or till that you can say 122 maybe, and 0 to 9. 0 is represented by basically 48 to 57. You can add 9. So these are the range given by American Standard Code ASCII chart. So whenever you press capital A, it will convert into 65. 65 will be converted into binary form, and later on, whatever, like B will be 66. Small a will start from 97, and 0 start from 48. So these and other control code means control key like arrow, control key. It is asking what basic control key like arrow or any other non-numeric key or character which has given 32 control code. So it is almost, but 2 power 7 means it can only represent 128 character. It can only support 128 character. Okay, later on, they have introduced another version of ASCII, which I tell you. Control codes are used for non-printing function in text communication and data processing. Okay. So you can see these are ASCII chart, American Standard Code for Information Interchange. Here you can see. Wait a second. Now, see this one, 65. No, you don't need to learn. You only remember. I tell you. You only need to remember for capital A 65. Next one, obviously 66 would be B. 65 is equal to A, and 66 equal to B. So you can count on fingers to find out the particular character. And same like small a, you only need to remember three character code. For capital A is 65, small a is 97, and for 0, okay, it is basically 48. That's it. Only 3 characters you have to memorize. For next one character you can count on your fingers. Okay. Now see, 60C is B. Now here you can see. Okay, they have also given hexadecimal code. 65 decimal means 41 in 41, not 41, 41 in hexadecimal, and in character form it is A. Now here you can see basically there is another logic. You can add 32 and 65. If you do not remember if you remember 65 is capital A. So you can add 32, it will be 97. So 97 will be small a. Here you can see 97 is given. Okay. And 61 is the hexadecimal and small a is the correct. Just only if you could not remember small a character code, only remember 65. That's it. Only remember 48 for 48. So here you can see might be 48 given like here. See here 48 decimal code 30 here you can see 0. Okay, and 9 basically 57 and 39 is the hexadecimal. You got the idea? Yes, Nama. You got the idea? Should I move to next slide? Okay, good. So moving to next slide. Now extended ASCII. What they have done basically, initially ASCII code was 7-bit. Later on they increase 1 bit more so that they can support more characters. This gives another 128 code to allow for character in non-English alphabet and for some graphical character tubing. So what they have done, they increase the range of characters. They from 128 to 256. For that purpose, 2 power 8 equal to 256. Okay. Now this is called extended ASCII. So now this is the standard we are following. We're still following. So it means now 8 bits equal to 1 byte. Okay. And 1 byte means only one character. That could be anyone like capital A or small a or 0. Okay. These 3 kind of characters. Any character from the keyboard you will use, it will take only 1 byte. 1 byte means 8 bits. So normally extended ASCII code is implemented by all computers for input data. You got this point? Is this clear? Should I move to? Okay, good. Okay. Now there is disadvantage of ASCII code. ASCII can't represent non-Western language like Chinese and has inconsistency between system. Okay, this is the disadvantage. So here, okay, here you can see 8-bit code. This is the ASCII chart for 8-bit code. ASCII uses 8-bit code 02255 in binary or 0 to FF in hexadecimal. Here you can see further characters are supported by ASCII extended ASCII chart. Okay. So due to limitation of ASCII and extended ASCII, computer engineer invented another standard code to support every kind of language. That is called Unicode. That is called Unicode. So I'm showing you Unicode. Unicode. Unicode is a versatile encoding system that covers all global languages. Okay. 1 second. Okay. Unicode can use up to 4 bytes per character, while ASCII uses only 1 byte. Now here you can see at ASCII could support only 7-bit, means only 128 characters. Later on, they introduced extended ASCII. Okay, it was 8-bit. Okay, it can represent 256 characters. Okay, okay, but this was insufficient. Initially, then they introduced Unicode. Initially, Unicode support 16 bits. Okay, now you can imagine 16 bits. It can be, I think, 65,000 characters can be supported. Later on, they introduced 24-bit. I mean 3 bytes. So it can support 3 point something million, 3.1 million characters. Now they have 32-bit characters. Okay. So you can imagine it can be billions kind of. Now I heard that it has introduced 128-bit. 128-bit billions characters can be supported by Unicode. You got this idea? Okay, is this clear about Unicode? Okay, good. So, okay, wait a second. Now it says ASCII and Unicode share the first 128 character. Both are same, but Unicode expands support significantly because it can support 16-bit, 32, 24-bit, 32-bit, and 128. Even 64-bit, later on 128. Here you can see the list of characters given by Unicode. Okay. Here you can see a sample of Unicode character are shown in figure 1.7. As can be seen from the figure, character used in language such as Russian, Romanian, and Croatian cannot be represented in a computer. So every kind of language can be supported by computer, and for that purpose, they have basically they have made a character set Unicode. So in world, there are three systems are running. Two system I have told you. Okay, the one is ASCII. Second is ASCII, extended ASCII. This standard is on normally followed by IBM system. IBM use this one, ASCII, extended binary standard code information interchange, and the universal Unicode. This is followed by every kind of computer. This is Unicode. ASCII is not in core, but you have to learn. You need to know about ASCII and Unicode. So now we will see further exercise. Okay. Okay. Here is the exercise of basically American Standard Code for information intelligence. Now it says character is another type of data. Okay. Character is another of type. The following table show part of the ASCII code character. So character set, code character set. Describe how the computer uses ASCII code to represent character. Okay. So we have to tell the process how this process is performed for the character set. Okay. Now here it says each character has a unique character code, as we have discussed earlier. Okay. This one I have discussed. The binary value for each character in the string is stored in sequence. Character code means it, like capital A will have 65, and this 65 will be converted into binary form. Okay, the binary value for each character in the string is stored in sequence, as you have seen in the list. ASCII code may be 7 or 8 bits. So it is asking about only ASCII, so you can tell these three features for 2 marks. Okay, you got the concept of this? Yes, Naima. Is this clear? You got this? Okay, good. So I'm moving to next one. Okay, now see, convert the following string into ASCII code. Can you do that? Yes, Naima, can you do that? Convert the following string into ASCII code. Should I help? Okay, you try. Okay. Just you have to tell basically capital B ASCII code, small e ASCII code, small d ASCII code. Should I help you? So now see here. Now see here. 66, 101 and 100. As I told you, capital A is equal to 65. So B will be equal to 66. Okay. If you do not remember, small a, just add 32, it will be 97, and 97 is equal to small a. Okay, it was asking about E. Now you can see what will be the code of E. B, C, D, E. So it means this will have 98, this will have 99, this will have 100, and this will have 101. So this one is the for E, this is for capital B. Okay. So next one is basically D. This is D. So here you can write D. Is this clear? Yes, Nama, is this clear? This part is clear. Should I move to next? Okay, it will come in next part. It will come. Okay. Even this is only basically you have to memorize from capital A to Z. Capital A start from 65. So for further letter, you just to have to 1 plus 1 will be 66, and this will be B. For 67, okay, it will be C, capital C. For 68, it will be D, capital D. Okay. 69 will be part E. So okay. For F, you got it? Okay. Good. So moving to next. Give the dictionary ASCII code for the following character. Okay. This basically question is missing. Leave it. Okay. Now see here this one. Complete the table by writing the ASCII code dictionary value for character T and its hexadecimal equivalent. Okay. Can you do this one? Okay. Okay. Try this one. Okay. Wait a second. I tell you. Tell me first, dictionary value. What is the dictionary value for small t? Can you tell me? Hexadecimal is wrong, but first you have to tell dictionary value, and that dictionary value can be converted into hexadecimal. Can you do? Yes, it is right. You are right. Ternary value is 116. That's right. So I can write here. It is 116. Okay. Now what about hexadecimal? Can you do? Should I help you? Just you have to convert 74. Okay, you are right. This is okay. Excellent. Okay. These are the right answers. You can see on screen. Okay. Now see here. Text and number are example of data stored in a computer. A character set is used to represent character in a computer. Describe what is meant by character set. The description, as I have shown you in the earlier slide, that description can be written on this question. Can you do that? Can you write some description? It is a 2 marks. Yes, Naima, can you do? Do you have book? You can see from the book. If you have a book, so you can see from the book. Character sets are defined by a collection of character and symbol. They consist of 7-bit or 8-bit code. Or you can say they were consist of 7-bit earlier. Later on, they were now they are 8 bits. Okay. Somehow your definition is right. So I can show you there. Okay. Wait a second. So it says all of the character or symbols that the computer can use or represent. Each character has a unique number or binary number or hexadecimal. So you have to tell each character has a unique number, binary number, or hexadecimal. Okay, you got the answer? Okay. Identify 2 character sets and state one difference between them. So it is asking further another character set. Identify 2 character sets and state one difference between them. Okay. So its answer you must have seen before that, like that. You can write ASCII, you can write extended ASCII or Unicode. ABSTIC is not included in syllabus, so you do not need to give. ASCII has 7-bit, whereas Unicode has 16. So one difference you have to tell. Here you can write the difference, or you can say ASCII extended ASCII has 8-bit, whereas Unicode has 16-bit, or you can say ASCII has 7-bit, whereas 8-bit. Unicode can represent more characters than ASCII or extended. Or by example, you can give the example. Extended ASCII can represent more characters than ASCII. So you got the answer? Is this clear? Okay. Now I'm moving to next another topic that is sound. Okay. Wait a second. Okay, so next topic is sound. Give me 1 second. Okay, you can go through. Okay, so sound waves are vibration in the air. These are some basically basic description. The human ear senses these vibrations and interpret them as a sound. Okay. Each sound wave has a frequency, wavelength, and amplitude. These are some characteristics I will discuss in next slide. What they are. Okay. The amplitude specify the loudness of the sound. Okay. So it's basically height. It shows the height of the sound. Here you can see basically they have shown basically two diagrams of sound, high and low frequency wave signal. The first one is high frequency wave. Period means wavelength. Okay. And its height is called amplitude, and frequency means repetition of the waves. So this is called high frequency wave, and at the bottom it is called low frequency wave. Okay. So these two diagrams given in the books. Okay. Now see next one. First one is frequency. Frequency refer to the number of occurrences or cycle of repeating event. So within a specified time period, often measured in hertz. So here you can see in diagram from you can see cycle per second. We call basically cycle, frequency means cycle per second from here to here or here. So this is called basically frequency. If you have heard about, if you know physics, I think in physics this topic is taught. You might have heard. Okay, is this clear, timer? So what is meant by frequency and wavelength and amplitude? Do you have idea about frequency, wavelength, and amplitude? Okay, good. So moving to next slide. So this was the definition of frequency. This is measured in hertz. Now wavelength. Wavelength is the distance between two consecutive points in a wave, typically measured from peak to peak or trough to trough. So here, so we can backward. So these two distance, this is called basically wavelength. Okay. So amplitude is the maximum displacement or height of a wave from its equilibrium position, representing its strength or intensity. So it says amplitude, how basically loudness of sound is basically adjusted by amplitude. Sound waves vary continuously, okay, and this could not be measured by a computer. That is why we have to say do something else. This means that sound is analog, okay. So you can see that sound is analog, kind of these. A signal could not understood by a computer, so we have to do something else. Computer cannot work with analog data, so sound waves need to be sampled in order to be stored in a computer. Sampling means measuring the amplitude of sound wave. Okay, so just remember, sampling means measuring the amplitude of a sound wave. This is done using an analog to digital converter. ADC is used when we speak. There is an ADC in sound card which converts our sound or voice into digital form. This is done using analog to digital converter. To convert the analog data to digital, the sound wave are sampled at regular time intervals. Okay, so they have time within the time they have to take samples. So the amplitude of the sound cannot be measured precisely. So approximate values are stored. Okay, this thing is clear. Up till now is clear. Yes, Naima. Now here you can see basically these are sound amplitude and these are basically time interval. So at time 0, it is giving 10 samples. Okay. At time between 1 and 2, it is giving 3 samples. At time 3, it is giving almost 9, between 9 and 10 samples. So that is why it was telling us they are not precise. So you have to be estimated. Okay. Okay. A sound wave being okay. Here you can see figure 1.9 shows the sound wave. The x-axis shows the time interval when the sound was sampled 1 to 21, and the y-axis shows the amplitude of the sampled sound to 10. Okay. A further explanation is coming. At time interval 1, the approximate amplitude is 10. So at time interval 2, the approximate amplitude is 4, and so on for all 20 time intervals. So you can see again at time interval it says approximate 1. Okay. So each time interval it will have a different sample, sound sample or sound amplitude. Okay. Now it says because the amplitude range in figure 1.9 is 0 to 10, then 4 binary bits can be used to represent each amplitude value. For example, 9 would be represented by the binary value 10, 100. So in your course, basically this sound sample will be given. Okay. Increasing the number of possible values used to represent sound amplitude also increases the accuracy of sample sound. For example, using a range of 0 to 127 gives a much more accurate representation of the sound sample than using a range of, for example, 0 to 10. So it says basically it means if we increase these sound sample 127, now right now it is 0 to 10, but if you can increase 0 to 127, so this sound will be more a sound will be produced in a better quality. It will produce further better quality. Now you can see how sound is generated from the computer using these techniques. Only the main reason is to increase the number of samples in a given time period. This point is clear. The number of bits per sample is known as sampling resolution, also known as bit depth. So I will tell you what is that. So in our example, the sampling resolution is 4 bits. Okay. So it is also called bit depth. Okay. Sampling rate is the number of sound sample taken per second. Sampling rate is the number of sound sample taken per second. This is measured in hertz. So where 1 hertz means 1 sample per second. So according to that, question will come. So when you solve the question, this topic will be clear further. So how is sampling used to record a sound clip? The amplitude of the sound wave is first determined at set time interval, the sampling rate. This gives an approximate representation of the sound wave, and each sample of the sound wave is then encoded as a series of binary digits. Okay. Using a higher sampling rate or larger resolution will result in a more faithful representation of the original sound source. So this was the theory related to your sound. However, the higher the sampling rate or sampling resolution, the greater the file size. So if you increase your sampling rate or sampling resolution, so it required a higher file size, so greater file size. So greater file size means you have to have space in your computer like RAM and hard disk, and you need to place more bits. So it says, okay, now tell me up till now it is clear. Should I explain further? Yes, Nama. Okay, good. Wait a second. So basically, these are some benefit and drawback. Benefit is larger dynamic range. You can assign better sound quality, less sound distortion if you assign more sampling resolution. It says the benefit drawback of using larger sampling resolution when recording sound. Drawback means produce larger file size. For that purpose, you need to have more space in your hard disk or RAM. Takes longer to transmit or download music files, so require greater processing power. You must have heard about MP3, MP4. So MP3 takes lesser space as compared to original CD music. So CD music were very larger file and better sound quality. So if you want to have sound with better quality, you need to have more space in your hard disk. CD have a 16-bit sampling resolution and a 44.1 kilohertz sample rate, that is 44 1000 sample every second. Okay, these sample we will use in our question, in upcoming question, to measure file size. So it will ask you file size and also it will ask you sound file size. Okay, these two types of question will come. We need to understand. This gives high quality sound reproduction. Okay. The number of bits used to represent each color is called color depth. Okay. Have you heard about color depth? I will explain further. Have you heard about color depth? Do you know that? Yes, Nama. Can you tell me? Do you know color depth? What is meant by color depth? The number of bits used to represent each color is called color depth. We also call it basically bit per pixel. Okay. Now you can see. Okay. Color depth means, just wait a second. This topic basically is also called bit per pixel. Okay. Bit per pixel means our basically screen shows image using a bit or pixel. Do you know about pixel? First, you need to understand pixel. Pixel basically it's a tiny or teeny point of basic point of light. Whatever we are seeing on screen, it is a light. This and this light basically is combination of pixel. Pixel means tiny point of light. These pixels are arranged like this one. I'm putting a dot. These are pixels. Pixel basically smallest element of picture. Smallest. So you can see pixel produce image and combination of pixel. I can tell you combination of pixel horizontal and vertical makes a picture. Make a picture or image. Okay, as you can see this one. This is vertical and this is horizontal. The screen is basically combination of vertical and wide, and this is height and this is width. The screen is basically a combination of height and width, and these pixels are arranged vertically and in width and horizontally. So these arrangement of pixel makes an image. These pixels required a bit. Pixel basically each pixel required bits. If I assign one pixel, if I assign one pixel 1 bit, so this 1 bit can produce only 2 colors. 2 power equal to 2 power 1 equal to 2 colors. So it can only produce. So as I increases number of bits to pixel, so number of color will increase. Like if I assign pixel 2 bits, so it will have a 4 color. Yes, Rama, is this clear? So I will explain further. Do you know? Bit per pixel or color depth. You must understood. You need to understand. If I give more bits to pixel, like 3 bits to a pixel, it will produce 8 colors. Okay, so on. If I give pixel 4 bits, 2 power 4, it will be 16 colors. Now 2 power 8, it will produce 256 colors. Do you know when at this point video started in computer? Before that, video could not be played on computer. So later on, 2 power 16, 65,000 colors can be produced. Okay, 2 power 24 bits means 3.1 million colors. Okay, 3.1 million colors. So now our screen basically has 32 bits. Okay, so millions or billions color, 2 power 64 or 2 power 128. So millions, billions and billions color are being produced by monitor. This is called color depth bit per pixel. Yes, Nama, you got the idea? Okay, is this clear? It will be clear gradually when you solve the question regarding this. But right now, I was telling you about bit per pixel or bit. Okay. So I'm removing this one by moving to next slide. Okay. It says an 8-bit color depth means that each pixel can be one of 256 colors. Okay. As I told you earlier, because 2 power 8 equal 256, modern computer have a 24-bit color depth, which means over 16 million different colors, or sorry, it was 16 million color can be represented uh, with multiply pixel. 2x color can be represented as a generalization. Increasing color depth also increases the size of the file when storing an image. Okay, as you now you have heard about basically 2K monitor or 4K, 8K LED. Okay, this is related to this bits per pixel. Image resolution refer to the number of pixels that make up an image. For example, an image could contain 4096 into 3072. These are number of pixels. Now you can see I was telling about 4K. Basically, this arrangement related to 4K monitor. You might have heard about 8K monitor. Have you heard about 8K monitor? Do you have LED? Yes, Naima. Do you have LED at home? So how much? Okay, it is 4K or 8K. Which one? Do you know that 4K or? Okay, good. So that 4K represent basically this resolution. These number of pixels. So according to that, basically LED can produce color. Okay. Okay. Wait a second. Okay. Now say the resolution can be varied on many cameras before taking, for example, digital photograph. Photographs with a lower resolution have less detail than those with a higher resolution. For example, look at figure 1.1. Here you can see different color depth. The most fuzzy picture is E, and D is better than E, C is better than D, B is more better than C, and A is most recognizable picture. As you increase your color depth or bit per pixel, picture will be more clear, or it will have a better quality. For 5 images of the same car, we using different resolution. Okay. Image A has the highest resolution and E has the lowest resolution. Okay. So E has become pixelated. We call it fuzzy. This is because there are fewer pixels in E to represent the image. So if you decrease pixel, image will be pixelated. If you increase pixel, the picture will be more qualitative, more bright. Okay, is this clear? This point is clear. The main drawback of using high resolution image is the increased file size, because next topic will be file size. Yes, Nama, till now is clear. Okay, it says as the number of pixels used to represent the image is increased, the size of the file will also increase. This impact on how many image can be stored on, for example, a hard drive. Okay, it depends the file size. Okay, it also impact on the time to download an image from the internet or the time to transfer images from devices. That is why we have to use compression software to compress the file whenever you want to transfer file from one computer to another using it. Because high resolution file will take more time. A certain amount of reduction in resolution of an image is possible before the loss of quality becomes noticeable. So compression software use the basically two techniques, lossy and lossless. You must have heard before that. Is this clear? Yes, Nama. Up till now it is clear. Okay, okay, no problem, no issue. So I will upload this video so you can see it again, and I will send you question on these. Okay. Next topic would be file size. Okay. Okay, Allah Hafiz. Okay, Allah Hafiz.